By the time artificial intelligence became the biggest story in technology, Nvidia had already spent years building the tools that AI companies needed. The A100 GPU became one of the most important chips in the AI boom. For many companies, the number of A100s they had became a way to signal their seriousness. If a startup said it had access to thousands of A100s, investors paid attention. If a large technology company announced an enormous GPU cluster, people understood that it had serious AI ambitions. Then came H100, the next major step. H100 delivered much stronger performance for AI training and inference, and demand became extremely high. AI labs, research groups, and large internet companies all wanted access to Nvidia's highest-end data center GPUs. This was not only about training models faster. For AI companies, compute became a form of strategic capacity. If one company had more GPUs, it could train larger models, run more experiments, serve more users, and iterate faster. In a field where model quality often improves with more data, more parameters, and more training runs, access to compute became a competitive weapon. That is why Nvidia's chips became more than components. They became a bottleneck in the AI economy. This created a powerful feedback loop. AI companies wanted Nvidia chips because the software ecosystem was mature. Developers optimized their models for Nvidia because that was where the hardware was. Cloud providers bought more Nvidia systems because customers demanded them. And as more people used Nvidia, the ecosystem became even stronger. This is why Nvidia's data center business became the heart of the company. For much of its history, gaming was Nvidia's most important business. GeForce graphics cards were the brand people knew. But as AI and accelerated computing grew, data center revenue became the center of the story. Nvidia also changed what it sold. It was no longer just selling a chip on a board. It began selling complete systems and platforms. It acquired Mellanox, an Israeli networking company, to strengthen high-speed data center interconnects. That acquisition turned out to be extremely important because large AI systems are not just collections of GPUs. They are networks of GPUs that must communicate quickly. If the chips are fast, but the connections between them are slow, the system becomes inefficient. So Nvidia expanded deeper into networking, servers, and full-stack data center design. It built DGX systems. It developed Gracehopper platforms that combine CPU and GPU capabilities. It invested in NVLink, NVSwitch, and other interconnect technologies. It built software layers for enterprise AI. It moved toward offering not just hardware, but entire AI computing infrastructure. This also allowed Nvidia to move closer to the customer, instead of only selling chips to hardware manufacturers. Nvidia could sell full systems, reference designs, software stacks, and cloud-accessible computing power. That gave the company more control over the user experience and a larger share of the value created by AI infrastructure. This is why Nvidia's transformation is so important. A simple graphics card company sells components. An AI infrastructure company sells the foundation that other companies build on. That shift also explains why Nvidia's valuation has often looked extreme. If you value Nvidia like an ordinary hardware company, the stock often looks expensive. The price-to-earnings ratio can look high. The price-to-sales ratio can look high. Compared with older chip companies, the valuation can appear difficult to justify. But investors are not only paying for current hardware sales. They are paying for the possibility that Nvidia becomes the central supplier of AI computing infrastructure. In that view, Nvidia is not just selling chips. It is selling access to the most important scarce resource in the AI economy: compute. This is why people often compare Nvidia to a company selling shovels during a gold rush. The comparison is useful but incomplete. In an ordinary gold rush, selling shovels may be profitable at first, but shovels are easy to copy. If too many companies start selling them, margins fall quickly. Nvidia's shovel is not a simple tool. It is a platform made of advanced GPUs, CUDA, software libraries, drivers, developer tools, networking, server systems, supply chain scale, and customer trust. That is much harder to copy. This is also why the competition is not only about chip specifications. A competitor can announce a fast accelerator, but customers also care about software compatibility, model support, reliability, developer familiarity, cloud availability, and the cost of switching. Nvidia's lead is partly technical and partly ecosystem-based. That does not mean Nvidia is invincible. In fact, its success creates several major risks. The first risk is valuation. When expectations are extremely high, the market becomes unforgiving. If revenue growth slows, if margins weaken, if supply catches up with demand, or if customers delay orders, the stock can move sharply. Nvidia has experienced large drawdowns before. It is a great company, but not a risk-free investment. The second risk is customer concentration and customer competition. Nvidia's biggest customers include cloud providers and major technology companies. These companies need Nvidia, but they also do not want to be permanently dependent on one supplier. Google has its TPU chips, Amazon has Trainium and Inferentia, Microsoft, Meta, and others are investing in custom AI silicon. These companies may continue buying Nvidia products, but they also want alternatives. This does not mean Nvidia disappears, but it does mean that some customers will try to move part of their workloads to internal chips, especially for cost control and strategic independence. The third risk is export controls. Advanced AI chips are now part of geopolitical competition. Restrictions on selling the most powerful AI chips to certain markets can affect Nvidia's revenue and product strategy. Nvidia has responded by designing compliant products for specific markets, but policy risk remains. The fourth risk is competition from AMD and specialized AI chip companies. AMD is trying to compete in data center accelerators. Startups and established chip companies are developing ASICs for specific AI workloads. Some of these products may be cheaper or more efficient for certain tasks. Nvidia's lead is strong, but the chip industry never gives permanent safety to anyone. That is one of the most important lessons from semiconductor history. One successful product does not protect a company forever. A chip that looks dominant today can be outdated in a few years. A new architecture, a new manufacturing process, a new workload, or a new software platform can change the balance. This is why Nvidia's true advantage is not just one GPU generation. Its advantage is the ability to keep running. The semiconductor industry is brutal because the cost of staying competitive is enormous. You need world-class engineers, advanced design tools, manufacturing partners, software developers, customer support, and the willingness to invest billions before you know whether a product cycle will work. Nvidia has repeatedly pushed itself into new territory. It moved from graphics cards to programmable GPUs. It moved from gaming to accelerated computing. It moved from selling chips to selling systems. It moved from hardware to a full software and platform ecosystem. That ability to keep expanding the meaning of a GPU is what made Nvidia so powerful. It also explains why Jensen Huang's long-term decisions matter. CUDA did not look like an obvious goldmine in 2006. Investing heavily in GPU computing before the market existed required patience. Supporting researchers, developers, and niche scientific workloads required endurance. Building data center systems required moving beyond the company's original identity. By the time AI became a mass-market obsession, Nvidia had already done much of the hard work. That does not mean the company simply predicted everything. No one could have perfectly predicted the timing of cryptocurrency mining. No one knew exactly when deep learning would become commercially explosive. No one could have known that large language models would become one of the biggest technology shifts of the decade. Nvidia benefited from luck. But luck only helps if a company is prepared. Nvidia had prepared for years. It survived the early graphics wars. It built GeForce into a consumer brand. It invested in CUDA when the payoff was unclear. It gained from the crypto wave. It then became the default platform for AI training and data center acceleration. That is why Nvidia's rise is not just a story about a company catching a trend. It is a story about a company building the infrastructure that allowed it to capture the trend when it arrived. Still, the next stage will be harder. And when a company becomes as important as Nvidia, everyone wants a piece of its market. Customers look for alternatives. Competitors copy what they can. Governments pay attention. Investors raise expectations. Every product cycle becomes more important. The AI market may continue growing for years, but Nvidia will have to keep proving that its platform remains the best place to spend AI infrastructure dollars. That is the real race. Not just selling more chips this quarter, not just releasing one more powerful GPU. The real race is whether Nvidia can keep turning compute into a platform and keep that platform ahead of everyone else. From gaming to scientific computing to crypto mining to artificial intelligence, Nvidia has expanded what a GPU can mean. Today, Nvidia is not really selling graphics cards, it is selling compute. And in the AI era, compute is one of the scarcest and most valuable resources in the world.